Located a few minutes from the Rotterdam Central Station, the Pathe building stands on a square in an area under active construction. The void created by the square gives the building a unique interaction with the city and the public and commercial life surrounding it. However, if we look at the facade, it appears old, dirty, and thus unwelcoming. This is due to all kinds of filth being retained by the corrugated shape of the panels and the lack of maintenance thereof. If one were to look carefully at the building, one would see that the facade is simply a shell that wraps around various volumes. In fact, if one were to strip away the shell, the architectural concept becomes clear. The previously mentioned volumes are used as projection rooms, whereas the space in between connects them. Moreover, it becomes a space in which one can enjoy coffee while waiting for their film to start. Taking a look at the blueprints, we can clearly see three kinds of spaces, all of which are surrounded by the exterior shell. The screening rooms, which are individually insulated spaces, the sheltered and temperated foyer, and lastly, the uncovered exterior spaces. Surprisingly, the thermal insulation study shows that the U value of the shell only varies slightly when covering either an untempered exterior or tempered interior spaces. The only difference between these two is one additional layer of polycarbonate, which is supposedly aimed to create an insulating buffer zone. Of all three types of spaces, only the projection rooms appear to be adequately insulated. The lack of insulation in the foyer is due to the way the outer shell is detailed. By combining two types of facades, second skin facade and cold cavity facade, the shell of the Pathe loses efficiency and the heat created by the heating system is quickly lost. Additionally, the surroundings of the building create one side more exposed to solar radiation than the other. This aspect is uncontrolled by the current disposition of the building. By enclosing the foyer and thus creating different climate zones, we see an opportunity to take advantage of that phenomenon. The controlled temperature difference air exchange can happen in the void created by the roof structure truss and the hollow space layer in the construction of the stele floors. The separation would bring some other, even more important benefits, like taking advantage of the already high insulation of the screening rooms and creating another climate zone between those insulated spaces. The present translucent facade blocks a significant part of the solar energy from entering the interior space. If it was constructed from a transparent material, the solid boxes could be cladded with heat-absorbing material. That would smoothen the differences between the temperature peaks and lows. Pathe has 7 screening rooms of an average capacity of 400 visitors. The energy created by the visitors in the rooms and the energy needed for heating the air in the rooms can be reused by using this used air for heating the vast open spaces outside the boxes. The building is standing on top of another one. The underground parking lot keeps a lower temperature than the exterior in summer and warmer in winter. This can be used for preconditioning the incoming air.
The heating and cooling principle of Académie Montigny can be taken as a reference. The air flows in through the underground air ducts and is preheated in the winter before it flows into the units. The building units have a heat exchanging compartment on top. Here, the exhausted air which flows into this compartment exchanges heat with the air of the buffer space. In the summer, it's pre-cooled. The air flows in through underground air ducts and also through openable doors and facade parts. The air is introduced into the buffer area and from here flows out through openings in the roof. The vegetation which grows in the summer also stimulates the regulation of the climate.
After examining these 4 opportunities, several questions arise. How can we take advantage of the already high insulation of the screening rooms? How can we minimize the energy consumption by creating 3 or more different climate zones, including a possible buffer zone? How far can we decrease the U value of the final envelope by this separation? How can we take advantage of the underground parking lot for air preconditioning? Is it possible to reuse the already heated air from the screening rooms?
Can we use heat-absorbing cladding for the screen room boxes?